Okay, this video is going to be covering composite functions and forming a composite equation that matches the graph. All right, so first thing I would say is when I say you're going to have to form a composite to match the graph, that's going to look like this, like a h of m of x, okay? This is a composite, and basically it's saying whatever's on the inside got plugged in. So m of x here gets plugged in for the letter x of the outside function. So h of m of x here, you really need to be good at looking ahead when you do this. So if I plugged in m of x, this 1 over x plus 1 that I circled, if I plug that in for the letter x up above it where the arrow is pointing, it would look like this. 1 over x plus 1 would be the part that I just plugged in, and then it would have the minus 1 at the end. So when it's all said and done, this would cancel. And so h of m of x would just be 1 over x. That's what I'm referring to when I say that you're going to have to make a composite that matches the graph. So look, there's about half of you that won't understand this after watching the video. I'm sorry. To the other half, pay attention and just kind of try to do a little trial and error and see these equations as you go. So if I approach this, I'm on number 1 here. The first thing I do is I write down the equation of the line. This one has a slope of -2 with a y-intercept of 0. So this is just -2x. You can put plus 0 if you want, but I'm not going to. I have to use 2 or more of these equations to make that -2x. So I'm going to, I found this one. I think I'm just going to show you a couple examples and see if you pick it up or not. Imagine if I plugged in -√x right there. So I had -2, but instead of writing the letter x, I wrote -√x, and then it was squared. If I did this inside part here, -√x squared, it's just going to become positive x, right? And I didn't mess with the -2 out in front. I just made it work. I just found this equation from the first one by plugging j of x into g of x. So I took j of x, I plugged it in to g of x as a composite. So I substituted this letter x right here for -√x. Kind of did a little bit of algebra, and guess what? It matched my equation. Now, it matters the order that you put these in, because if you were to put like j, this is what not to do. If you were to put like j of g of x, then you're plugging g of x, which is -2x squared, into this letter x of j of x. So it would look like -√, and then instead of writing the letter x, I would write g of x's function, which is -2x squared. Look how different that is than this -2x that we wanted. So the order matters. Whichever one gets plugged in, like in this first example, the j of x got plugged in, that one goes on the inside of your answer. See how it's on the inside here of the g of x? Okay, if you're still with me and you're not confused yet, good job. If you're already confused, just give me a shot. Let me show you a couple answers, all right? Look at this next one. It has a y value of 1. That's the equation. Let me get rid of this. This next one has the equation y equals 1. So I have to form a composite that ends up with just a value of 1. I'm going to use f and I. And by the way, when I do this, like myself, and I don't already know the answers, guys, I'm trying everything. I'm plugging f of x in here. I'm plugging f of x in here. I'm doing everything that I can. You kind of have to do a little trial and error. Sometimes it's easier. Like if you know it's going to be a squared function or an absolute value, it kind of narrows it down for you. But if it's like a linear, it can get kind of challenging. All right, so I'm going to use, to get this one, I'm going to use f and I, right? So if I were to plug in f into I couldn't because there's no x there. So that's not an option. All right, but what if I plugged I into the f of x function? So it would look like 2, instead of writing the letter x, I write -1, and then I have a +3. Do the math, you'll get -2 + 3, which is 1, which matches my composite graph. So this answer, I plugged I into f of x. So I was on the inside because it got plugged in to f of x, which is on the outside, like that. Okay, this next one, let me get rid of this stuff. This next one's a rational function. Rational functions by default are 1 over x. Well, this one's basically the parent rational. It just got shifted over 1 and up 1. So the equation of this line is 1 over x. It got shifted 1 to the right and then up 1. So I have to find two equations that, when put together, form this composite. Now, just looking at my equations, this right here is really close. I just needed, instead of x here, I needed x minus 1. Well, what if I had x minus 1 that I could just plug in there? I do. It's right here. So if I just plug in this x minus 1 for that x, I would have this equation. So h is being plugged in, h of x is being plugged into m of x, like that. Maybe I should have started with that example because it worked out pretty nicely. Okay, moving right along. This next one, I know it's a quadratic, and they tell me a is a fourth. So I know it's going to be like a fourth x something squared. Did I shift left or right at all? Yes. My vertex, I shifted right 1, so x minus 1. And I shifted down 3, so minus 3. So now I glance up here at my equations. Hey, this one right here is really close. If this letter x had just said x minus 1 again, like this, it would have worked. So that's going to be, that x minus 1 is going to be what you're going to plug in there. So h is being plugged in to p of x, like that. And again, the order really matters, because imagine if you said the answer was h of p of x, saying that p was getting plugged into h of x. Well, that would look way different. That would look like 1/4 x squared minus 3. But instead of writing, oh no, this is correct so far. And then you would have the minus 1 from the original h of x. So you really have to pay attention, because this one would have given you 1/4 x squared minus 4. That is not correct. That does not match this graph. So pay attention as to which one actually gets plugged in where. All right. And if you're still confused, I'm sorry. I'm so sorry. This is a very difficult topic to try to explain. This next one is a linear function. It has a slope of 2. It has a y-intercept of 2. So I got to make this thing say 2x plus 2 somehow, using 2 or more of these equations. This one, any linear, you're going to just have to, basically you can kind of think of it as, in order for it to linear, it's either got to be like a linear plugged into a linear, or like a constant plugged into a linear, or like a root that gets squared would give you a linear. But any absolute value or rational, or mainly kind of even quadratic, those are kind of out of the question. I know, having said that, this first one used a quadratic and a root. It was a rarer example. Most of the time, if it's linear, you're going to use linear to make it. So this one, you're going to use like h and f. And you're kind of going to have to just do a little trial and error. So if you plugged in f into this h of x right here, you would have 2x plus 3 minus 1. Well, that's 2x plus 2. That's how you get this equation. So I plugged in f of x into h of x, like that. The next one is probably going to be a little easier for you to see because it is a negative root function. This is a negative square root. So the equation of this is negative root x minus 1, like that. So I have to use two of these equations. Well, I know one of them is going to have a root. So I know one of them is going to be j of x, because j of x is negative root x. Now I just got to have an extra minus 1 here. So I'm looking over here at h of x. And basically, I'm just going to take j of x and plug it in for h of x. And if you did that, you would get negative root x minus 1, just like that, which is the equation we want. So j of x got plugged in to h of x, like that. All right, moving right along. The next one is a quadratic. They tell you a is 4, so it's going to start out like 4 parentheses. You'll have an x here. It'll be squared, but I don't know much else. I know that it's negative because it's going down, so it's really negative 4 out in front. Then I know my vertex, hk, is 0, 3, so there's no shift here as the horizontal, so I can get rid of this. It's just going to be x squared, but there is a shift up 3, so plus 3. So it's got to say negative 4x squared plus 3. In order to make this, I'm going to use, well, I know I have to use a quadratic, right? So that's, I'm going to use this one, g. And I'm going to do a little trial and error until I get it. So, okay, I'll show you what it looks like when you actually do some trial and error and you can't figure it out. So like, I'm using g of x, negative 2 x squared. I'm going to try plugging in h of x. Well, this equation does not match. You know what I mean? That's what I'm talking about when I say trial and error. So instead of using h, I'm going to use f of x. And I'm going to go and plug in g into my f of x. Because if I do this, I'll get 2 negative 2x squared, the part that got plugged in, plus 3. Distribute the 2, you get negative 4x squared plus 3, which is what I wanted it to be. So I plugged in g of x into f of x, like that. Okay, this next one, I know it has to be an absolute value function. So I know I'm going to use k of x. The question is, which other equation would I use for it? So I'm going to find out the actual equation of this line. If you look, you'll notice that from vertex to the next point, it rises 1, runs 2. So it got vertically compressed. It's like a 1/2 before those absolute value bars. Then it also got shifted left 3. So it's like a x plus 3 in those bars. So this is the equation of this line. Now looking at my k of x, it already has the 1/2. Or well, I need that inside part to say x plus 3. So if I change that x to be x minus 1, when I combine that minus 1 and that plus 4, it'll make the plus 3 I'm looking for. So I'm going to plug in h of x into k of x. Because if I do that, it would look like this, 1/2 absolute value bar. Instead of writing x, I write x minus 1, then plus 4, then close the bars. These are like terms, the minus 1 and plus 4. So it's going to make 1/2 absolute value of x plus 3. which is what I want. So h of x got plugged into k of x. All right, and this last one is a quadratic, so I know I'm going to use something with a quadratic most likely. It's going down, so I know it's negative. They tell me a is 2, so it's -2. It shifted right 1, so x minus 1 squared, and then it didn't shift vertically at all. So this is the equation I have to match. I'm going to use g and h to make it happen. So if I change this x squared right there, if it said x minus 1 squared, it would match my equation that I'm looking for. So I'm going to plug h in right here because it'll look like this. It'll look like -2, parentheses. Instead of writing x, I write x minus 1, and then it's squared. That matches. So h of x got plugged into g of x, like that. Guys, if you watch this whole video and you still are just like, I have no idea what he's talking about, again, I apologize. This is a really, really difficult topic to try to explain, but my advice to you is kind of do trial and error and just imagine, like, if I plugged in something for something else, would it make my graph match? So be able to find the equation that you actually should be looking for and be able to do enough trial and error until you get it. Good luck. Hope this video helped.